Hello friends, let's have a look at problem 3323. Minimize connected groups by inserting interval. This is a newly appeared problem, so in this video we are going to analyze the details and share some code tweaks and tunes. First, we are going to give a quick overview of the statement. So here we have a list of intervals. So each interval is represented by a length 2 list, right? Starts and end. So we must add exactly one new interval. So this interval has length at most k. So after adding this interval, we hope to connect some intervals, right? So the problem is required to return the minimum number of connected groups after adding exactly one new interval in the array. So here we have two examples. So here k is 3. So you can imagine if k is very large, right? They can join all of those. Then the output will be 1. For example, k equals, so here 1 and 10. So 100, for example. So it's more than enough, right? So here k equals 3. For example, if you start from 3, then you add 3 to 6, right? This is an interval. So you can connect these two, right? Or if you start from here, you can connect these two. So overall, you will get two groups, right? Either you connect these two to form a group, and then this is the second group, or this is the first group, and this is the merged group, right? So this is 2. So in the second example, here you can see 1, 1, 3, 3, and 5, 10. These are 3 disconnected intervals. So if you want to add a length 1 interval, so it will not connect anything. So the output will be 3. So here the constraints are the following. So here is the length, which is large. Basically, we need to take time complexity into consideration. So this is a closed interval, right? And this is the range for start and end. Both are bounded by this number, 10 to the power 9. Also, this is the key. So this is the main problem statement. So now let's analyze the main idea. So here first I would say this is the interval merge type problem, right? So we have a playlist which you can check out those problems. If you have watched the previous videos on those problems, it would be rather straightforward to come up a solution with this one. So basically, the two ingredients in this video to solve this problem. One is merge intervals. So this is rather straightforward after sorting. Another one is binary search, right? So because we want to check, how many intervals we can cover using a length k closed interval. This is the main this is the main idea. So now with that said, let's carry out this program, and in between we are going to explain the ideas. So I guess solving the problem itself is not our main purpose. So we want to digest the ideas and do some tweaks and tunes to better digest or grasp the main ideas, both in the problem statement and also in coding. So now let's look at the first one. So in order to, for convenience of typing, I changed the intervals to be capital I, right? So first, in order to merge the intervals, we need to do, let's make a mark. So step 1, merge intervals, right? So this will give us this, after the merge, we're going to get a list of disconnected intervals, right? So this is rather straightforward. Let me introduce n is the length of this list, and then we're going to sort this one. So mainly according to the start of the interval, but by default in Python, if you have it high, so they're also going to sort according to the second component for elements in I. So this is the preparation work. So now I want to use groups. So this will hold the merged intervals. Then basically it's a for loop. So for I in range m, right? So notice that now we have sorted this interval. So the starts will from small to large, and also the end will from small to large if no ties. If there were ties, then for the same start, the end will be also from small to large. So now what we want to first get the current interval, that is I of I, right? So now we are going to check if this is a start. We are going to just add to the last group to the group as a new group. If we have overlap with the last element in the group, so we are going to merge. If not, we are going to start a new group. So basically, if not groups, in other words, this is the first interval, or I equals 0. In this case, we are going to do groups append. So this interval S and E, right? So otherwise, so the groups is not empty. Then we are going to compare the previous start, previous E. So this will be groups -1. So actually, you can see we are mainly focusing on this one at the present time. So now, if S is greater than the previous E, right? In other words, the current interval S and E and the last group has no overlap. Then in this case, what we are going to do is group append S, E, right? Otherwise, so we can merge the current interval with the last interval in the group, or the last group. What we can do is do the following groups. So we don't need to change the previous, because we know, right? We know previous S is less than or equal to S, right? So essentially, what we want to do is to replace the last interval, last group, to be previous S and max previous E and the current E. So that's the main logic. So, but we don't need to pop and then form a new interval. We just need to modify the let's see, previous E and the E. Yeah. So what we want to do, actually, we can modify the groups -1, then the second element. So we're going to make it to be previous E and current E. So this is our grouping, right? So now we can do a test. So we can print out the groups so that you have an idea. So for this one, it does not change, right? So we can do, maybe try this one, right? So for this, we should have 1, 5, right? Let's do it. Yeah, we have 1, 5. So far we get this one. This is good. So next, what we want to do is step 2. So we want to check how many intervals we can cover at most, right? Using a length k closed interval. So this is actually we need to check. For example, this one. Let's use the first example to example 1 to make understanding, right? So we have 1, 3, 5, 6, and 6, 8, and 10. Then the starts actually is 1, 5, 8, and the ends are 3, 6, and 10. So then if we start from the first interval, in other words, I equals 0, then the interval will be 3 plus 3, that is 6. So this interval, so if we look at this end, this is 3, which means that we can connect these two, right? So if we insert find insertion point for 6, so the 6 is nothing but which is 3 plus 3. So the first 3 is the end, and the second 3 is the key here, right? So then the insertion point in the start will be, so insert 6 into 1, 5, 8. So the index will be 2, right? Which means that these two intervals can be covered, right? So similarly, if you start from, say, the second interval, so in other words, you start from 6, then the interval will be, so in other words, I equals 1, right? The interval will be 6, then 6 plus 3. So you get none, right? So none, if we can cover this one because it can touch 8. So basically we insert none into 1, 5, 8. So the index again, so the index will be 3, but we start from the second interval, or the interval at index 1. So in other words, the intervals from index I up to the index minus 1 can be merged, right? So this is our main idea. But in reality, for example, there will be something is, for example, the end can be this end computed can be the same as this one, right? You need to insert in the last one. For example, you have 5. You should insert here. The index will be 2, not 1, right? So this means that we need to pay attention to insert left or insert right. So with those heuristics, now let's look at the second step. So in order to better understanding the procedure, or for pedagogical purpose, I will isolate the starts. So the start will be atom 0 for atom in groups, and the ends will be, so I can copy this one, right? So this will be atom 1, right? Then we are going to start from each interval and then to see how many intervals we can merge, right? So basically for, let's see, for I and the end in enumerate, so ends. Then what we want to do is that if we end at here, then the interval we are going to consider is nothing but end plus key, right? So we want to see if we insert this endpoint to the starts, how many interval we can cover, right? Then the index, let's use the bisect module. So we want the left is less than or equal to this point. So because as long as touched, we can merge. So basically, this is the iterable we want to insert, and the element we want to insert is end plus key. Notice that we are using bisect right, means that so for this IDX, so starts J less than or equal to end plus key for all J less than the IDX, right? So once we have this, what does it mean? It means from index I, so this is the ith interval, right? Because we connect from this, and then say, let me write like this, intervals at indices I plus 1, so up to, because this is the insertion point, so we need to IDX plus 1. So the intervals with this indices can be merged, right? Merged. Then in order to prepare the return, so we can first we can get let's see the length. So this is the number of groups, right? Then the answer will be the length at most, right? Then here, if we start from the current interval, so we can merge this number of intervals. So the count, let's see, the count is idx, so not +1, -1. So the end index minus the start index, that is I, and then +1. So in other words, idx minus I intervals can be merged. So how many groups we have? So let's see, originally we have this number of groups. Then we minus these groups. So this is the remaining groups, but these intervals forms one group. So we're going to increment one. This is a new group counts, right? So this will be length minus idx and then plus I, then +1. So now, because we want to find the minimum one, so we want to do min answer and new group counts, right? Then afterwards, we just need to return the answer. So this is the main coding part. So here we write in a very verbose way for the purpose of showing you the details. So let's see. It passes one example. Now let's look at the generic case. It passes all the cases. So this basically finishes the coding part. So now I want to make some remarks. So let's not not modify the original code. Let's make a copy, and then we'll change this version to be version v1. So what I want to see is that, so here we consider this interval, and then we use bisect right. But if you want to use bisect left, you can do something like this. Because here we want the left to be less than or equal to this number. In other words, it's strictly less than this number, right? So this will be bisect left. You can also use this. So this is the one option, right? Option of using bisect right. So now for this one, let me this is for using bisect left, right? So this also works. So yeah, this is a very subtle detail. Then another thing is that I also want to copy again, and then let's call this one version v2. But you may notice that when we do the group, we are actually interested in the starts and end, right? So we can directly get all of those. So in order to get groups, we can see we can add some starts and ends, right? Then let's ignore this part, these two lines. So when we do the for loop, so this is the start and end. So if not starts, so in other words, we haven't formed any group yet. So what we are going to do is starts append s and ends append e, right? So otherwise, so here press start and press it will be something like this. You can change this to be starts and ends, right? So if s is greater than press end, So we form new groups. So in this case, what we're going to do is do the same thing here. So otherwise, so actually we don't change the start, but we change the ends. So the ends -1 will be max of let's see, the ends previous E and current E. Actually, even this is actually redundancy. We just need to modify it to be this E. That will be enough. So now let's check this. After this merge, we automatically have starts and ends, right? Then all the other remaining parts does not change. Starts. So where is it? Starts. So here. Yeah, let's submit that. Yeah, again, you can choose to use bisect left or bisect right. So that's basically nothing special. So here, let me delete this part so that we have a better visual effects. So, and also make it longer. Yeah, this will be another version. So I guess with up to now, we finished coding and the problem. So here we explained the procedure as merge interval tab, and then we did a binary search, and we compare some coding styles and coding details. Hopefully this will help you digest this problem. If you like this videos, you're welcome to follow other videos in our channel so we can study together.